Hello everyone, welcome back. Okay, for my last Lagrangian video, I had a glitch. The audio sync wasn't going along with the video. So I hope this one works out. I hope you understand every single detail that I have to give to you. Knowledge is power actually, so let's get to it. So we have a function where our utility function is equals to q1 raised to power 1.5 and then q2 raised to power 1 is invisible. It's subject to this is the budget constraint. 3q my 1 plus 4q2 is equals to 100. I've already showed you this is the utility function and the budget constraint. Okay, so let's get to it. Let's solve. Okay, our question is, will the consumer maximize his utility on the purchases from q1 to q2 and q2? So let's solve. The first thing you do is to rewrite your budget constraint. I know what a budget constraint is. Okay, this is the budget constraint. 3q1 plus 4q2 equals to 100. So when we're writing this, we'll have it as this way: 100 minus 3q, taking all this things over to the side of 100. So we have 3q1 minus 4q2. So we've rewritten our constraint. Next thing is to multiply this constraint with the constant we're making use of. And the constant we're making use of is what we call the Lagrange. This is the Lagrange multiplier. So next up, we'll multiply it with the Lagrange. Okay, let's do that. So we'll have it in this way: 100 minus 3q1 minus 4q2. When we open up the brackets, we'll have it this way: 100 Lagrange minus 3q1 Lagrange. I don't know how the pronunciation is, trust me, I'm not Latin. It's a Latin word actually, under the Latin alphabet. So this is this. So next thing is to add our utility function, that's q1 1.5, q2 raised to power. Yeah, we're adding it with this: 100 Lagrange minus 3q Lagrange minus 4q Lagrange. Okay, the next step is to find the derivatives of all the variables that we have here. We have 3 variables. We have q1, q2 and line. So we're going to derive all of this. Are you ready? Okay, let's do it. Let's use dv over the q1. So we are deriving with respect to q1. So when we derive this, we'll have 1.5 q1. So you know how to do your derivation. This minus 1 will give you 0.5 q2. Q2 has to be there because it's like a product form. In case you're having problems with this, you can comment on the comment section to really put you through on the steps and rules of differentiation. You know, we have product rule, quotient rule, and so many more of them. I could put you through to that. So in this 100 lambda, are you seeing any q1? No, so we can't differentiate that. This one we see a q1, so we are going to differentiate it. And where we do, we have minus 3 lambda. What of this? Nope, no q1. So this is for our dv dq1. So we're going to derive it next one, which is dv dq2. We're going to come back to this. So eyes open, keep your eyes open. So what's our function? Let's check it. We have this. So we're deriving with respect to q2. So for the first one, the anything up here is just 1. 1 times 1 here is 1. So we just have 1. Our q1 is still there, 1.5, and our q2 is out because 1 minus 1 is 0, and the raised to power 0 is 1 log indices. So we have to look for where we can find q2 again. Any q2 here? No. q2? No. q2? Yes. So when we differentiate that, we'll have 4 lambda. So the last and not least differentiation, let's do the dv d lambda. So okay, let's go back. Any lambda here? No. Nope. Yes. So let me derive all these ones with lambdas. 100 lambda is just 100 minus 3q1 minus 4q2. So this is it. This is what we have. So the next step is now to equate some equations that we have. Like we have, let's call this one equation 1, this one equation 2, and the last one equation 3. The 1 divided 1 is equation 1, divided 2 is equation 2, divided the lambda is equation 3. So now next step, we're going to divide equation 1. You can use, yes, we're going to divide equation 1. Divide equation 1 by equation. But before we do that, there's something we have to do. We have to equate all of this that we have to 0. We have to equate them to 0 first before dividing. So for the first one, the equation 1 is 1.5 q 0.5 q2 minus 3 lambda equals to 0. So let's take this 3 lambda over. We're equating it, so we'll have 1.5 q1 0.5 q2 is equals to 3 lambda. Anything that goes over an equal sign, the sign with it will change. Like here we have a minus sign, a negative sign. When it goes over, it has a positive sign. Don't write it, you know it's a positive sign. So now we're gonna do the same with the equation 2. We're gonna equate it to 0, and when we do that, we'll have q 1.5 is equals to 4 lambda. So let's divide now. We have let's divide. We have 1.5 q1 Okay, so what can go? Law of indices is applying here. Law of indices, if you have notes, law of indices, I really need to have another video for this law of indices. If you have something like this, q1 3 all over q1 2, this is the same with q1 3 minus 2 because of this what division sign. But if it's something like this, q3 dot q2, this is q3 plus 2 because of the multiplication sign actually. So in this format we have q1 here and q1 here. So we're gonna do what we have to do. We have this q 0.5 minus 1.5 q2 equals to, this lambda can cancel out, so what we have left here is 3 over 4. Okay, so when we minus this thing out, what do we have left? We have minus 1 left, right? I don't want to be wrong. Okay, well, we make mistakes actually. So close to 3 over 4. Sadly, the law of indices is also applying here. Should I show you? N raised to power minus sign q raised to power 1 is equals to 1 over q1. If you have q raised to power minus 2 is equals to 1 over q2. So here we have q raised to power minus 1, we have 1.5 q2 all over q is equals to 3 over 4. So next thing we do here is to cross multiply and make q1 the subject of the formula. So let's start. It's a really long procedure. When we cross multiply, we have 6q2 equals to 3q1. So I said making q1 the subject of the formula. Divide all through on both sides by 3. q1 is now equals to 2q2. So let's call this equation 4. let's call this equation 4. So we have to input this equation 4 in either equation, no, we just have to input it in equation 3, so we can get the equation 2. Okay, our equation 3 is this. This is our equation 3. What's our equation 3? Let's check. Sorry. Okay, this is our equation 3. We're going to equate to 0. 100 minus 3q plus minus 4q2. Okay, let's get to it. Oh, this is glitchy. Sorry. Okay, 100 minus 3q1 minus 4q2 equals to 0. So we are inputting our q1. 100 minus 3 2q minus 4q2. So open the bracket. 100 minus 6q2 minus 4q2. So what we do here is 100 minus 10q2 equals to 0. Oh, call it like times. We have minus 10q equals to minus 100, and we divide by the coefficient of q2. We have q2 is equals to 100 over minus 10, which give us 10. So we've gotten our 10, but we've not gotten our q2. So this q2 that we have as 10, we can impute it in our equation 4. What's our equation 4? Our equation 4 is q1 equals to 2q2. So when we impute it, we have our q1 as what? 20. q1 as 20. Oh, we have our q1 as 20.